Hello, this is Ms. DB, and today we are going to learn about arithmetic sequences. This is from Chapter 4, Section 6 of your textbook, and our objectives are to recognize and extend an arithmetic sequence. That's when it says to write the next three terms, and also to find a given term of an arithmetic sequence, like maybe the 100th term. So during a thunderstorm, you can estimate your distance from a lightning strike by counting the number of seconds from the time you see the lightning until you hear the thunder. Have any of you ever done that before? So you might see the lightning and then start counting and go 1, 1,000, 2, 1,000, 3, 1,000. And when you hear the thunder, then you stop counting. And if you write the times and the distances in order, it forms a sequence, and you can see that there'll be a pattern. And each number in a sequence is a term. So that's just one example of a sequence. Another example of a sequence might be listing all the even numbers, 2, 4, 6, 8. So that's a sequence. Here's an example with the thunder and the lightning. When the storm is 0.2 miles away from you, it might take 1 second. When the storm is farther away, it takes longer. And then you can add from the distances, you can add the differences and see if they are, you can find the differences and see if there's a pattern. And you can see that there is. Each distance is 0.2 miles greater than the previous distance. So what we call this is an arithmetic sequence because the terms of the sequence differ by the same number d. We call that 0.2, that is our d, our common difference. It's an arithmetic sequence because there is a common difference between each of the terms. A lot of times we'll use the variable a to represent terms in a sequence, like a sub 9 means the 9th term in a sequence. A sub 1 would mean the first term in a sequence. If you're just talking about any term, like it could work for any of them, then you'd use a sub n, where n could be any number. And d, again, is going to be the common difference. So we have a lot of vocabulary, a lot of terms and variables that you need to know what they stand for. Remember that a is a term, and d is the common difference. So if we want to find the nth term of an arithmetic sequence with a common difference d, we could do that by taking the term before it, which would be n minus 1, a sub n minus 1, plus the common difference. Let's look at some examples to see what we mean by this. Here's an example of a sequence, and we want to see if it's an arithmetic sequence. So we have 9, 13, 17, and 21. What you want to do is subtract the two terms that are next to each other. So take like 13 minus 9. 13 minus 9 is 4. Okay. Take 17 minus 13. Well, that's also 4. Take 21 minus 17. That's also 4. So you can see that if we just added 4 to each term, you would get the next term. So 9 plus 4 is 13. 13 plus 4 is 17. 17 plus 4 is 21. So that's a pattern. That's an arithmetic pattern. So this is an arithmetic sequence. So our first question would be yes, this is an arithmetic sequence. Now that we know it's an arithmetic sequence, we know that the common difference we found on this page was 4. The common difference is 4. So now you will use that d equals 4, and you will add that to the 21, and then you'll add 4 to the next term, and then you'll add 4 to the next term. So 21 plus 4 is 25, 25 plus 4 is 29, 29 plus 4 is 33. They only asked us to find the next 3, so we would stop after that. Okay, if you see 3 dots at the end of a sequence, they're called ellipsis, but what they mean is, and so on, and it continues in this same form. So here's those 3 dots at the end. They're called ellipsis, and they mean it's going to continue in this same form. So let's check and see if this is arithmetic. We go from 10 to 8 to 5 to 1. All right, so if I want to take the difference between 10 and 8, that would be 2. So I'm decreasing by 2, so that would be minus 2. Then from 8 to 5, it goes down by 3, and from 5 to 4, it goes down by 1. Now, there is a pattern, but this is not arithmetic. Arithmetic has to be you adding the same number each time. Even if that number is a negative, that's okay, but you can't change the common difference because then it's not a common difference. So this is not arithmetic, so then you do not have to find the next 3 terms because it told you only to do so if it was arithmetic. Now we could probably say, well, maybe next we'd subtract 5, but we're only looking at arithmetic sequences for this assignment, so you don't have to try to figure it out if it's not arithmetic. Here's an example where we go from -4 to -2 to 1 to 5. To get from -4 to -2, you would add 2, and then you would add 3. So there's no common difference. It's not the same difference. So then, therefore, this is not arithmetic, and then you would be done at that point. Here's some problems from your assignment that are very similar to what we just did. Now, the first two, 7 and 8, already have the common difference found. So you just need to keep that pattern up. Notice that in 7, we're adding -3 each time. So I'm just going to do one of them. If you take -2 minus 3, you get -5. And then you go -5 minus 3. So you're going to be going more and more negative. Let's look at number 10 with the decimals. We need to figure out what is the difference between 1.25 and 3.75. What did we add to 1.25 to get 3.75? So to find out, subtract them, and then we'll know what we added to get to that answer. So this is plus 2.5. Now we don't know if this is an arithmetic sequence yet, so now we need to check if that's the same from 6.25, or from 3.75 to 6.25. So we'll subtract again, and you can use a calculator to subtract if you'd prefer that. And we get 2.5 again. Now we'll have one more check to do, and that is 8.75. Sorry, my cord was wrapped up around my tablet here. 8.75 minus 6.25, and that's also plus 2.5. So every time we added plus 2.5, so our common difference is 2.5, and then we just need to keep adding that number, 2.5, to our previous term in order to find the next term. So our next term would be 11.25, and then we would add 2.5 to that, and you have 2 more to go. All right, to find the nth term of an arithmetic sequence when n is a large number, like 100, you don't want to have to keep adding on to your previous number until you get to the 100th term. So we're going to find another rule, another formula in order to do that. So in this pattern here, we have the first term is in position 1, and it's 3. And then in position 2 we have 5, and in position 3 we have 7, and in position 4 we have 9. So we would write those term numbers as a sub 1, a sub 2, a sub 3, a sub 4, and then for the nth position we just write a sub n. So the sequence starts with 3. That's our first term, is 3. The common difference is 2 because we're going up by 2 each time. We can use those two things, the first term and the common difference, to write a rule for finding the nth term, a sub n. And here is how we do that. We are going to, this is the math behind it, how it works. And what we use is the formula right here. Where's my pen? Pen tool, there we go. So here is how it ends up being the formula. If you take the term number you're looking for, subtract 1 from that, multiply by the common difference, and then add that number to your first term, you will get the nth term that you are looking for. And this is on your worksheet. This is the overall formula that you'll be using to find the nth term when you're looking for like a big term, like the 100th term or the 50th term or a big number. If it's just like the 4th term, you would just keep adding. Okay, so here we want the 16th term. So we first figure out what the common difference is. So the common difference here is 4. That's D. D is equal to 4. Okay. We also already can tell on here that the first term is 4 as well. That's not always going to be the same, but this time we also started with 4. So now we're going to write the rule. That's all we really need, and we also need to know that they're looking for the 16th term, which is our n. So we have that n is equal to 16. The first term is 4, and we just found that D was also equal to 4. So now we plug those into, here's our formula. So a sub 16, the 16th term, would equal 4 plus, then we use our n, that was 16. 16 minus 1 times 4. Now make sure you use your correct order of operations. You need to subtract that 16 minus 1 because that's in the parentheses. And then you need to multiply. Do not add the 4 to the 16 and then go from there. So 16 times 4 is, or 15 times 4 is 60. So we would get 60 plus 4, or 4 plus 60, and then our answer is 64. So the 16th term of this sequence is 64. All right, let's try another one. In this one, we're looking for the 25th term. Where's my pen now? Here we go. So our n is equal to, come on, pen. Our n is equal to 25 this time. Our first term of our sequence is given to us as -5, and our common difference is -2. So here's our formula that you'll write down. A sub n equals a sub 1 plus parentheses n minus 1 times d. So we substitute in our values. And then remember to do the work in the parentheses first. So 25 minus 1 is 24. Then multiply. And 24 times -2 is -48. And finally, we will add -5 plus -48 and get our solution of -53. So the 25th term is -53. Okay, here's just another example. This time they're giving us the sequence, and this time we'll have to figure out what the common difference is because they don't tell us. So it looks like the common difference is -6, so that's our D. We also can tell that A is equal to 60. Come on, pen. Okay. My pen doesn't want to work today. But A is equal to 60 because it's right here. And D we now know is -6. And what's the other part we need to know? We need to know A sub 1, which is 11. That plus 2 got left over from the page before, I think. So we plug in all of our numbers where they belong, and then you subtract 60 minus 1, do the work in the parentheses first, is 59. And then take 59 times -6. I'm not sure what that is. -354. And then finally you will take 11 plus that -354 to get our final answer that the 60th term of this sequence is -343. This is just another example to practice. Sometimes they give you everything you need to know and you don't even have to find the common difference first. Like in this case, they give us that D is 1.4, they give us that A is 4.2, and they're looking for the 12th term, so we use that for n. Don't forget to do the parentheses first, which would be 11 times 1.4, and then you would finally add the 4.2 plus the 15.4. So 19.6 would be the 12th term of this arithmetic sequence. Here's some problems from your worksheet. You can see that they're very similar. In the first example, we are given that the first term is 10, that the common difference is 4, and all we have to do is write this formula plugging those in. So let's see if I can get my, oh, there, I think it's working now. A sub n will be equal to, let's see, a sub 1 is 10 plus parentheses n, we don't know what n is yet, minus 1 times d, which will be 4. So for number 11, it's just asking for the formula with the d and the a sub 1 where they belong. Now in number 12, we are going to figure out what is the first term of this sequence and what is the common difference. You don't actually have to find the answer for this. We're just going to write the rule. So the first term is -5, and the common difference is, let's see, what would we add each time to get to the next term? It's 5 as well. So then over here, we're just going to write it in terms of n. We're going to write what is our a sub 1 plus, and we're just going to leave as n. And then for d here, we're going to put this. So you just have to plug in the rest of that. Now in 13 through 17, you're actually going to find the indicated term that they're looking for. So in number 13, they're looking for the 15th term. So n is 15. A sub 1, oh, they already wrote the formula. All we have to do is take what n is and put it right here, and then do the order of operations correctly. Do the work in the parentheses first, so that'd be 14 times -0.5, and then finally take 16 plus that answer. In number 14, again, the formula is already written out. You just need to take that n is equal to 32 and put that into the formula for n. Now 15 through 17, you'll actually write the formula yourself and then find the indicated term. So in number 15, we're going to find the 100th term. So n will be 100. We can see that a sub 1, that's first term, a sub 1 is -8. And now what's the common difference? We go from -8 to -6, and then from -6 to -4, and -4 to -2. It's increasing. The numbers are getting bigger each time, and they are increasing by 2. So I'm going up by 2 each time. So that means my common difference is 2. So you would take those and plug them into this formula, and then you'll simplify and solve and see what you get. In number 16, n is 25. The first term is a sub 1, and I'm not sure what the common difference is yet. We'll have to go from -14 to -6, and -6 to -2, and -2 to 4, and 4 to 10. The 4 to 10 one is the easiest. I know in my head that if I added 6 to 4, I'd get 10, so you can go back and check if that works for all of the other ones as well. And then once you know what a sub 1 is, what n is, and what d is, you plug that into the formula, simplify, and solve. Here's an application problem with the sequence. We have a bag of cat food that weighs 18 pounds at the beginning of the day, day 1. Each day the cats are fed 0.5 pounds of food. How much does the bag of cat food weigh at the beginning of day 30? So we're looking for n equals 30. At the beginning, it's 18, and our common difference is we are subtracting each time, so it is -0.5. So it's decreasing by 0.5, so our common difference is -0.5. So now that we know what all the variables stand for, then you will plug them into the formula. It started at 18 pounds, and then we want to know what it is when n is 30 after 30 days, and every day it decreases by 0.5. Make sure that you simplify the expression in the parentheses first, that's 29, then multiply, and then finally add. Don't forget your order of operations. So there will be 3.5 pounds of cat food remaining at the beginning of day 30. All right, go ahead and get your worksheet done and let me know if you have any questions. Thank you very much. Have a great day.